Welcome to The Explainer. Today we're taking a fascinating little journey right into your kitchen pantry. We interact with simple, everyday ingredients so often that we completely overlook the incredible, borderline mind-blowing scientific secrets they hold. And today we're focusing on a condiment that you probably have sitting in your fridge door right this very second. Yep, we're talking about mustard.
Think about it. What if I told you that this simple yellow paste, your absolute favorite hot dog topping, is secretly a biochemical powerhouse? Okay, let's dive into this, because the actual science behind mustard reveals it as a wildly potent antibacterial agent. We're talking about something capable of fighting off food spoilage in ways that modern food scientists are literally just beginning to fully harness.
But before we get to the modern laboratory, we really have to look back, way back, dating all the way back to 3000 BC. Long before it was ever just squirted onto a sandwich, mustard was deeply respected in ancient Ayurvedic medicine. It was heavily relied upon as a natural remedy to relieve severe gastric discomforts, things like cramps and flatulence. So its biological importance, that was recognized millennia ago.
And its ancient history brilliantly illustrates why scientists find it so utterly fascinating today, specifically when we look at its genetics. Many of the mustard plants we use are what botanists call an amphidiploid species. Sounds like a mouthful, right? Basically, this is a natural hybrid that actually combines the entire genetic blueprints, the diploid genomes, from two entirely different ancestral plant species. According to a famous botanical model called U's triangle, which maps out exactly how these distinct species crossbreed, mustard is literally a marvel of natural genetic engineering.
So, from that incredibly complex family tree, we essentially get the big three mustard types that are cultivated commercially all over the world. We've got Sinapis alba, which is your classic yellow mustard, Brassica ginsea, the brown mustard, and Brassica nigra, the black mustard. And hey, do not let their tiny seed size fool you. These seeds are absolute treasure troves, just packed to the brim with bioactive compounds waiting to be unlocked.
Now, what's really interesting about this is the sheer nutritional density hidden inside these tiny seeds. I mean, just look at this macronutrient profile. Mustard is almost 36% healthy fats and over 28% protein. That is an incredibly dense, plant-based nutritional profile for something we usually just brush off as a spicy flavor enhancer.
Seeing the raw agricultural harvest of these crops really puts that into perspective, doesn't it? When we look out at those vast fields of bright yellow flowers, we aren't just looking at a future condiment. We are looking at a highly efficient, nutrient-dense crop that serves as an exceptionally rich source of plant-based protein and dietary energy.
And this density becomes even more impressive when we zoom in on the micronutrients. Just look at these numbers. In a 100-gram serving, you are getting almost 700 milligrams of potassium, 345 milligrams of magnesium, plus massive hits of calcium and iron. Even just a small spoonful of mustard is delivering a highly concentrated dose of these essential minerals that literally drive our daily cellular functions.
But the real magic? That happens down at the microscopic level. 82.5%. That specific number represents the DPPH free radical inhibition that researchers observed in mustard seed extracts. In plain English, that means mustard acts as a microscopic shield, blocking over 80% of free radicals from causing cellular damage and oxidative stress during tests. I mean, that is a staggering antioxidant capacity.
Which brings us to a massive question. If mustard is such a powerful antioxidant and antibacterial agent, can it be used to solve one of the food industry's oldest, most frustrating problems? A fascinating study published in the PMC database put this to the ultimate test. I like to call it the meatball experiment. Could adding ground mustard to raw meatballs literally stop the meat from spoiling?
To actually measure this, scientists use a marker called T-bars. You can think of T-bars as a way to measure lipid oxidation in fat. Basically, lipid oxidation in meat is exactly like rust forming on a piece of metal when it's left out in the air. The higher the T-bars level, the more rusted or rancid the meat has become. Make sense?
So the scientists set up this strict timeline, keeping the meatballs refrigerated at 4 degrees Celsius. On day 0, they took their baseline readings. By day 4, natural oxidation begins. The rusting starts. By day 7, they started seeing a massive difference between the meatballs with mustard and the ones without. And finally, day 15, the threshold for maximum spoilage. Let's see how they actually held up.
The results were honestly striking. The control group, so the meatballs with 0 mustard, were highly oxidized, horribly rancid, and absolutely loaded with bacteria by the end of the 15 days. But the mustard group,
which contained just 2% ground mustard seeds, successfully halted that whole rusting process. The lipid oxidation was dramatically slowed down. And look at what it did to the bacteria. By day 15, the spoilage bacteria in the control group just skyrocketed to nearly a 6 log count, but the yellow mustard, it plummeted that count all the way down to 4.80. This proved, without a doubt, that simple yellow mustard is a ruthless defender against microbial meat spoilage.
Now, there was a catch to making this work perfectly. So the crucial point is this. They didn't just use raw mustard seeds right off the plant. Nope. They used an autoclave to treat the seeds with intense heat, 121 degrees Celsius for exactly 15 minutes. This specific high heat treatment was the absolute key to unlocking their true preservation superpower.
Here is the chemistry of why that heat actually matters. Treating the mustard inactivates an enzyme called myrosinase. By stopping this enzyme in its tracks, it stabilizes a compound called synalbin. This prevents the mustard from breaking down into compounds that would just taste completely awful in the meat. Plus, the heat dramatically increases the seed's antioxidant activity and just crushes the starting bacterial counts.
And of course, the ultimate test, the taste panel. Did anyone actually want to eat these? Well, yellow mustard didn't just preserve the meat. The meatballs with the autoclaved yellow mustard actually scored higher in flavor. They got a 6.65, beating the plain control meatballs. Black mustard, on the other hand, scored a bit lower because its unique chemical profile made the meatballs just a little too bitter for the judges.
So we've seen that mustard is this incredible, ancient, nutrient-dense, meat-preserving powerhouse. But science is all about balance, right? With all this intense chemical power packed into such a tiny seed, we really have to ask the toxicological question: is consuming large amounts of mustard entirely safe?
Well, here's the toxicological catch. Research shows there are absolutely several side effects and compounds to be aware of if consumed in excess. Mustard is a known allergen for some folks, causing hypersensitivity and skin irritation. Researchers also note the natural presence of compounds like bisphenol F and urusic acid, alongside oxalates and goitrogens. Let's actually look a bit closer at those last two.
So, raw mustard seeds contain goitrogens. A goitrogen is a naturally occurring compound that, if you consume it in very high, unbalanced amounts, can actually interfere with the normal functioning of your thyroid gland. This is a perfect example of a plant's natural defense mechanism acting as a bit of a double-edged sword for human consumption.
Furthermore, mustard is really rich in oxalates. As noted all the way back in Ayurvedic research, high levels of oxalates can interfere with your body's ability to absorb calcium properly. Now, for the average person, a little mustard on a hot dog is totally fine. But this poses a very specific dietary risk for people who are prone to developing kidney stones.
Ultimately, it all comes down to balancing the incredibly powerful chemistry of natural agriculture with safe consumption limits. Understanding the biology of this simple seed completely transforms how we view it, doesn't it? It's not just a condiment, it's a complex chemical factory capable of fighting bacteria, providing rich nutrients, and honestly, demanding our respect.
Which leaves us with this final thought to ponder today. If we are literally just now figuring out how to use heat-treated yellow mustard to safely extend the shelf life of meat, what other revolutionary scientific solutions are sitting completely unnoticed in your pantry right now? Thanks so much for joining me on this explainer, and as always, stay curious.